Talking about another problem in our fourth module, that is our memory allocation techniques. We have two kind of problems in this. I guess one is that about page displacement algorithms, which is the easiest one again, and this is also one of the problem which will be asked in the examination about memory allocation. This is contiguous, that is non-contiguous, this is contiguous. So here this one example question. So from this one example question you should be able to understand. So before starting with the question, okay, so three types are there, right? So see here, so there is a first fit, best fit, and worst fit. Another we have, but that's not in our syllabus, that another type of memory allocation. So for time being we have only three. So let me give you two examples. From these two examples it will be like crystal clear for you to understand what to do, okay. First example, see, I'm just giving example, so don't think what am I saying and all. So suppose, see, I'll just say one normal story. What usually happens when students are in either colleges or degree. So see here, this first fit now. So according to a sentence, it allocates the first whole that is big enough. To understand this, I can say like in colleges usually there some boys are there now, like they'll be like uh, attracted towards someone, so they just want to like someone. So now this first fit is like a boy. For the first time he sees someone good, the first girl he sees, he started liking that girl itself. So like that you can understand this first fit, the first thing which is which he sees good enough, so and he will start liking. Coming to the best fit, this guy sees from all the years, first, second, third, fourth year, and among that who is good, then only he will like select that girl to like. In first fit, what, as soon as he's found someone good, he will just select it to like. In best fit, uh, he sees all the years and selects who is good enough. But coming to the worst fit, it's like even after seeing like everyone from all the years, this guy goes for the like last year batch itself, who is eldest or elder to this guy. I know this was not a good example, but most of you understood. Coming to the proper decent example, it's like suppose you have some what to say, a bucket, okay. You have bucket, so I'll take example of this itself. Suppose these are your buckets, okay. Now you have a container like water, so you have a water and you have to pour water like in these places. So you have these many buckets, and suppose in this question, so you have 1 2 3 4 5, oh, how many processes, 1 2 3 4, yeah, 4 processes are there. Just think 4 glasses are there, okay, and 6 these are there. So you just have to pour like this. So how first fit is, first it will check here whether I can pour my like complete glass in this bucket or not. I'm just giving an example. If not, if it can fill, it will fill here. If not, he will go here. So as soon as it find the first one which is good enough, like big enough to pour all this water, it will select that and pour it. Okay. What happens in best fit? It will see every bucket, and which bucket is like not that much big enough, so it won't waste that much space. So it will fill water only in that bucket. Suppose this glass was having 100 ml. So which bucket's quantity, holding capacity is near to 100 ml, the nearest to 100 ml. So this might have for 110, this 105, this 107. So among these 105 is a close, so it will fill in that. Worst it is like it will see all the buckets which is having the highest quantity, it will fill in that first. Okay, so that's what there about this all three strategies here. So now let us solve this problem. Okay, so I'll just write this table here. Okay, so see, we have here 100, so these are 100, this is k, okay, here 500 k, 200, 300, and then we have 600. So let us see the question. Given memory partitions of so these all are the memory partitions of so and so k in order. Okay, how would each of the first fit algorithm place processes of these many things? So down I will write what are the processes have that memory. Okay, one has 212, 417, 112, and 426. Okay, k. Okay, now which algorithm makes the most efficient use of memory? Okay, so we have to see which algorithm makes the most efficient use of memory. So what you have to do, one by one take this, keep adding in this. So according to first fit, let us do. Now, so first fit, how it happens. So I'll write this here once, so that I can explain you easily. 417, 112, and this is 426. So now what happens? This thing is there. It will check. It cannot place it here. Second thing. So first thing it found big enough. It will place there. This guy checks, comes. First place big enough, place here. This guy checks, not here. First place enough, places here. Now see, for this what happens. This we cannot place anywhere. Okay, why? Because it is 426. Now in 500 a half is going, and in 600 400 is going. So remaining here also 200, here also some 200 change will be remain. So we cannot place this anywhere. Okay, I'm just saying. Okay, now coming to, after just showing this, I will solve that. Okay, then coming to best fit. So it sees everything which is the nearest thing to place this, it will place there itself. Now see, 212, it cannot be placed here, it can be placed here, no, cannot be placed here, it can be placed here, placed here. Among these three, which is the smallest one, this, so this will go here. Okay, 400, it can be placed here and here, which is smallest among this, so it will go here. 112, where it can be placed, it can be placed in 1 2. And now see that, now suppose 500 is there, na? So if you subtract this, where is the calculator? So see here, so 500 and 500 minus 417. Okay, 500 minus 417, so this will be 83. Okay, I will write like this. And here 600, sorry, 300 minus 212, that is also 88 itself. Okay, okay, so sometimes what happens, even after subtract, these places will have enough memory space such that this least lower numbers can be placed. So as you can see here, it can either be placed here, here, or here, not here, here and here. So it will place here. Now this will go here, and now as you can see here also some left out, here left out, here also left out. So when this goes here, even here also you have 88 free, and when this goes here, you will be having like 174, I guess. Let us check. 600 minus 426. Yeah, 174. Good. Okay, so here 100 is remaining. See, this is the best fit wala part. Now let us go for the worst fit. Okay, so now what happens, each thing comes one by one, which is the highest will go there. So see, this is the highest one, so this will go here. Second, which is highest, here. This, now where it is highest, this. Now this, again as you can see, this cannot go anywhere. Why it cannot go anywhere is because see, we need 426 memory space. So wherever these things are going, it's not leaving space itself. Okay, so this was one general thing. So now let us see calculate. Okay, so 100. So okay, one by one. So here we will write that whatever 212 na, 212k, 417, 112, 426, and down only I will write the table. 100, 500, 200, 300, 600. Now you can see. So see, now what happens. Now first thing, this first one, 1 2 3 4. So we have 4 processors. This some memory thing which you have to give. Now what we will do, first fit, इसमें डालेंगे, we will put in this as you know. 212 will go in 500. So what we have to write, 500 minus 212, which is equals to 218, 288. 212 is put in 500k partition, you have to write like this in, see, and then in the bracket what you have to do, 500 minus 212, the remaining is 288k now. So now what happens, this becomes 288k. Okay, so it's not 500 anymore. Now the second 417, it will be placing 600 wala isme. Okay, so 600 minus 417, which should be equal to 183. Yeah, okay, so you have to say right like that, 417k is put in 600k memory partition, and in the bracket put do the subtraction. So 183 is now 112, which is first enough, big enough to go place, it will go. So now as you see here 288 is remaining, right? Instead of going here, it will go here, it will 288. So 288 again minus 112. which is equals to, let me see here, 176. So now this is 176, it will change again, okay. And then 426, so where can it be placed? 100, 176, 200, 300, nowhere. So 426K process has to wait because it does not have a big hole to accommodate. So whatever we say hole in this, okay. So though we have, now you add all this remaining, okay. I will remove this, we won't take this and we won't take this. So 100 plus 176, 200, 300, 183. Okay, so if you add this total, how much memory space do we have? You can see here we have 1244K of memory free, but we cannot place this 426K process. That's the main problem we have in here, because why we are not able to accommodate. We have how much? 1, 2, 4, 4. Why we are not able to accommodate this? Because we have partition scattered the memory into different partitions. So here external fragmentation occurs. Talking about the best fit now, okay. So this all goes. So best fit. So where this 212 will go? It will be placed in 300K. So 300 minus 212. Let me just write directly, okay. So 500, here 200, here 600, minus 470, 112, 426, 88, 83, this is also 88, 174, okay. So I will change 174, 300 became 88, 200 became 88, 500 became 83. So as you can see, these all were changed and still we have this much amount of memory and all the processes were this. So 212 will go in 300 wala memory partition, 470 will go in 500 wala memory partition, 112 will go to which wala? This 200 wala, okay. And then 426 will go to 600 wala. So best fit like this. Then coming to the worst fit, what it does, which is the biggest one, it will see that and put what very greedy person. What was here? So see this 212 where it will go, highest वाला कौन सा है 600 ना, 212 will go in 600. What will be left? 388. Now you see this 417 it will go to 600 का हो गया, 500 is left, right. So here 500 के place में 417 will go, remaining is 83. 112 where it will go, highest is which one? 388, right here, am I right? Yeah, so it will go to 388. So 388 minus 112, which is equals to, just reduce, so 672, correct? Correct, basic subtraction. Then this 476, where can it be go? ये change हो गया to 83, ये change हो गया to 276. See, now you cannot place this anywhere, so you have to write again 426 process must wait because the memory is scattered and there is no enough memory to give here. There is enough memory, but in one hole you don't have that much memory. So here again external fragmentation occur. So drawback of this is we will get, not always, but we will get a fragmentation. Fragmentation will happen here. So for that drawback and all itself, we go for non-contiguous memory allocation, that paging and all will come here, okay. So this is all about your what is that memory allocation problem. What happens, they will give a table like this instead of writing here. So they will say this wala process ka nahi hai, already taken, so only the remaining part is left. So same thing, just don't go with the diagram, whatever is remaining you write like this one by one, up and down, okay. So as you can see here, 100, 300, 50, 200, 150 and 200. So you just write in table like this, and then how we solve the sum, the same way you can do this also and just complete the sum.